Hi there, this is Jude Socrates. Welcome to today's video where we will talk about the calculus of polar curves. So in our previous video, we learned how to plot points in polar coordinates and how to navigate the polar coordinate system. So today we're going to learn how to graph the curves produced by polar equations. So we will look at the curves which are determined by a function like r equals f of theta. And we are going to find points on these curves where the tangent lines are either horizontal or vertical. And if the curve passes through the origin, what we know as the pole in polar coordinates, we will look for the slope of the lines. There could be more than one. Where the curve passes through the origin. Okay, so let's go to our first example. Okay, so here's a function I like to introduce as our first example in my classes. So we have a simple equation. R is 8 cosine theta. Whenever we have a polar curve, more often than not, we have a trigonometric function involved. Okay, so cosine theta is part of this curve. Okay, so what we're going to do is we will make a table of points, and then we will go to GeoGebra and plot these points. Okay, we'll go from 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Okay, so do you know your trig? Let's see. Cosine of 0 is 1, so r is 8 times 1, which is 8. Okay, pi over 6. Cosine pi over 6 is square root of 3 over 2, so times 8, that will be 4 square root of 3. Okay, I'll need the square root of 3 there. There we go. Pi over 4. Cosine is 1 over square root of 2, or square root of 2 over 2. So we have 4 square root of 2. So I think I will copy this whole thing and change 3 to 2. Pi over 3. Cosine pi over 3 is 1/2 times 8. You get 4. Pi over 2. Cosine is 0. Yay. So 8 times 0, 0. 2 pi over 3. So now let's think about symmetry. 2 pi over 3, the cosine is negative 1/2. So times 8, we will get negative 4. Okay, so r, remember, in polar coordinates, r could be negative. When it's positive, it represents the distance from the pole to that point. But when it's negative, you go in the opposite direction. Okay, so we will see that in GeoGebra. So similarly, 3 pi over 4, the cosine is negative rad 2 over 2. So we will get negative 4 rad 2. So I hope you see there's some symmetry going on here. 5 pi over 6, cosine is negative rad 3 over 2. So times 8, we will get negative 4 rad 3. And then at pi, cosine is negative 1. So times 8, we are going to get negative 8. Okay. So, you know what? I forgot to mention that usually when we plot points, our input is on the left and our output is on the right. But our points in polar coordinates are given as r comma theta. Okay? So the input is theta, the output is r. So it's a little bit awkward. And so hopefully it's not confusing to you that we're putting the input on the right and the output on the left. So when we go to GeoGebra, in polar coordinates, the point is 8, 0. Remember that in polar coordinates, we want a semicolon between the two numbers to tell GeoGebra that our point is in polar coordinates, not Cartesian coordinates. Okay? So let us go to GeoGebra and plot these 3, 4, 5, 6, 7, 8, 9 points. All right, so I've gone ahead and plotted the first 5 points. So we have 8, 0, and there's the semicolon I was telling you about. So there is 8, 0 radians 4 rad 3 pi over 6 is here. 4 rad 2 pi over 4. 4 pi over 3. And 0 pi over 2. So if you're plotting these by hand, here are the first 5 points. So it looks like we're going from A to B to C to D to E. Okay, so if you're using a pencil or a pen, you'll just mark those off. Of course, we're going to cheat a little bit and ask GeoGebra to graph this for us. All right, so our next point is negative 4, 2 pi over 3. So I'm going to duplicate this, and we're going to have negative 4 and 2 pi over 3. Ooh, okay, so there is point F. And then we have negative 4 rad 2 pi over 4, duplicate input. Negative 4 rad 2, 3 pi over 4. Okay. And then next is negative 4 rad 3, 5 pi over 6. So duplicate input. And we have, there we go, negative 4 rad 3, 5 pi over 6. Okay, and our last point is at pi, we get negative 8 pi. So we will duplicate this, duplicate input, and we get lower negative 8 semicolon pi. Okay, so watch carefully. There's nothing there. Where did it go? That's because negative 8 pi, well, let's think about that. Pi is going to the left, but because r is negative 8, we have to go to the right. So it's actually right there. It's hiding behind point A. So here's what I'm going to do. I'm going to go up to A, and I'm going to hide point A. It's gone. There's point I. So A and I are actually the same points. Okay? So it looks like once we have gone from 0 to pi over 2 to pi, we're back where we started. Okay? That's not obvious, and I'm not willing to waste my time and go, okay, maybe let's try what comes after pi. Maybe we can try 7 pi over 6. Oh, and then we're going to be here where D is. Okay, it looks like we are retracing our steps. Okay, and also, just to review, we have this point F, negative 4, 2 pi over 3. So 2 pi over 3 is supposed to be in the second quadrant, making an angle of 60 degrees from the negative x-axis. But because the r is negative 4, we're going backwards by 4. So that's why we are down here. Okay, so the million-dollar question is, if you connect these 9 dots, what kind of graph are we gonna get? Okay, so, well, we could ask GeoGebra to graph this for us. All right, so to graph a polar equation, we will need the symbol theta. So we have r equals 8 cosine of theta. And yeah, so to be fair to you, when you call up the keyboard, this is what you will see. You click on the Greek letters, and then you can type in theta, or click on theta. Ooh, okay, so there is our curve. And yeah, it goes through all 9 points. Okay. Would you like to guess what exactly that curve is supposed to be? Yeah, anyone can see it looks like a circle. So maybe it really is a circle. So let us go back to our workroom and let's prove that what we're looking at really is a circle. Okay, so we know how to find the equation of a circle in Cartesian coordinates, not so much in polar coordinates. Our equation is r equals 8 cosine theta. So we know the conversion formulas to go from polar to Cartesian. We also know that x squared plus y squared in r squared. We're not going to use theta as arctangent y over x or whatever. Okay, so we see cosine theta in the equation for x, but we're missing r on the right side. So the logical thing to do is to multiply both sides by r. So r times r is r squared, and on the right side we will get 8r cosine of theta. Okay, multiply both sides by r. Alright, but now r squared is x squared plus y squared. So the left side is just x squared plus y squared. The right side we have 8r cosine theta. R cosine theta is x. So we get 8x right there. Okay, so that is optimistic because when we have an equation of a circle, we naturally get x squared plus y squared. Okay, so it looks like we're going to have to move the 8x over to the left side. So we'll get x squared minus 8x. On the right side, we're going to get 0. Okay. Hopefully you know what to do next. X squared minus x squared, we need to complete the square. Take half of 8, we'll get 4. Square it, we get 16. So we will add 16 to both sides. Plus 16 on the left, 0 plus 16 or just 0 on the right side. And there you have it, ladies and gentlemen. On the left side, we have a perfect square. This is the perfect square of x minus 4. X minus 4 quantity squared is x squared minus 8x plus 16, completing the square. On the right side, of course, we just get 16. So that is a circle of radius 4. The center is at 4, 0. Okay, y squared, of course, is exactly the same as y minus 0 squared. So the center of that circle that we just saw should be at 4, 0, and the radius is also 4. Let's double check. All right, so here's our curve, and that does look like 4, 0 is the center. That's the topmost point, bottommost point, rightmost, and leftmost point. Okay, so while we are here, let's see what happens if we change cosine to sine instead. All right, so let's see if that's going to work. Instead of cosine, we're going to change that to sine. Okay, are you going to change for me? And there might be some trouble. I'm going to delete this and put in a new function. Here we go. So now we have r equals 8 sine theta. So the circle used to be over here, and we started out at 8, 0, and it went like this. But now it's going to start over here, because when theta is 0, sine of 0 is 0. So we start at 0, 0 radians at the pole, and then we will go this way until we get to pi. Okay? So when it's cosine, it is symmetric across the x-axis, and when it is sine, it is symmetric across the y-axis. Okay? And that makes sense because sine of theta, if your theta is in this direction, then when you reflect that angle across the y-axis, you get pi minus theta. And sine of theta and sine of pi minus theta are exactly the same. So that is why this curve where, instead of cosine, you have sine, that curve is symmetric across the y-axis. Okay, let's go back to our workroom, and we're going to modify our circle just a little bit, but it's actually going to make a very big difference in the graph. Okay, so we started out with 8 cosine theta. We're just going to add 3 to the right side. Okay, so this was the table that we got in our last example. So we're simply going to add 3. So 8 plus 3 becomes 11. 4 rad 3, okay, just add 3. 4 rad 2, fine, add 3. 4 plus 3 is 7. 0 plus 3 is 3. Negative 4 plus 3 is negative 1. Ooh, okay, so it's still negative. And this is negative 4 rad 2 plus 1. I'm sorry, plus 3. And we will add 3 here. Negative 8 plus 3 is negative 5. Ooh, interesting. So it's going to go from positive 3 to negative 1. Wait a minute. So somewhere in between, this is a continuous function. Cosine is continuous. So somewhere in between, r has to be 0. Okay, that's interesting. But when we reach pi, we're at negative 5. Okay, so something funny is going on because earlier we started at 8 and we finished with 8. Okay, so now, because we're adding, I'm sorry, we finished with negative 8, but because we're at pi, we are back where we started. Okay, so this time we start at 11, 0, still on the x-axis, but now negative 5 pi, so we go to pi, you point to the left, I guess your left is over here, but then negative 5, we actually point to the right, so we go 5 to the right from the pole. Okay, so something very different is happening here, and it looks like we're going to need to plot more points. Okay, so let's add some more rows to this table. Okay, so remember it is 8 cosine theta plus 3. So after 5 pi over 6, you get 7 pi over 6. 7 pi over 6. Cosine 7 pi over 6 is still negative 4 rad 3. Remember, it's symmetric. So we will still get negative 4 rad 3 plus 3. That will go over here. Next, 5 pi over 4. But the cosine of 5 pi over 4 is also negative rad 2 over 2. So we will get this value with a plus 3. Okay, so next is 4 pi over 3. But cosine of 4 pi over 3 is also negative 1/2 times 8 is negative 4 plus 3 is negative 1. So of course, these values are also repeating. So keep going. What is next? I believe it is 3 pi over 2. And for that, we will get negative, it will also be 3. No negatives. And then we will get 5 pi over 3. And the cosine will be positive 1/2 times 8 is 4. Plus 3, we will get 7. Again, these values are repeating. After 5 pi over 3, we will get, what is that? 7 pi over 4. 7 pi over 4, the cosine is rad 2 over 2 times 8 is 4 rad 2, add 3. So we will get that number. And should we say finally? Oh, no, not yet. We have 11 pi over 6. And the cosine is rad 3 over 2 times 8. You will get 4 rad 3 plus 3. The same as for pi over 6. So finally, at 2 pi, is it time to say finally? Cosine is again 1, so times 8, you will get 8 plus 3 is 11. Is that where we started? Let's see. Let me make the magnification a little smaller. Yeah, there we go. So we see the whole graph. Now we're back where we started. Okay, we started at 11, 0. A 0 where radians were pointing to the left. Go 11. 2 pi, we're back to the same angle and the same r at 11. So it looks like we are back where we started. Okay, so yuck, we now have what, maybe about 18 or 19 points that we are going to have to plot. Okay, I think we should start over. All right, so I didn't want to leave you out of this. I have plotted the first 5 points, 11, 0, 4 rad 3 plus 3 pi over 6, 4 rad 2 plus 3 pi over 4, 7 pi over 3, 3 pi over 2. Okay, so I'm going to pause the video and then I'm going to plot some more points from our table. Actually, no, I changed my mind. I think you should see this because this is where it gets exciting. So we have negative 1, 2 pi over 3, semicolon, because it's polar, 2 pi over 3. So yeah, see how funny this point is. 2 pi over 3 is supposed to be over here, 60 degrees from the left. It should be 60 degrees. But it's negative 1, so we should be going backwards. Okay, so very interesting. What is next? Negative 4 rad 2 plus 3. So I'm going to, you know what, I'm going to copy point C, duplicate input, and it will be negative 4 rad 2 plus 3, and it will be 3 pi over 4. Okay. So 3 pi over 4 should be over here, but we're going backwards. So we end up over here. Okay, so this number is also a negative number. That's why we're going backwards. Next, minus 4 rad 3 plus 3. So we will copy point B, duplicate input, and we will put a negative sign over here. And it will be 5 pi over 6. Okay, so 5 pi over 6 is supposed to be here. This is still a negative number, so it's going to go this way, backwards. Okay, so next we have negative 5 pi. Negative 5, definitely a negative number. Negative 5 semicolon pi. Okay, so we are here. So remember before that A and I were both at 8, 0 because there was no plus 3. Okay, now there's a plus 3. So instead of negative 8, we're getting negative 5 pi. Okay, so it looks like we're going from here to here to here to here. And then somehow we make our way here. So I know how the story goes. And I know that because r is 8 cosine theta plus 3, somewhere in between, it has to be 0. So we have to pass through the pole somehow. And then we're going to pass through these points and then here. Okay, so now at this point, I'm going to stop the video and I am going to plot the rest of the 18 or whatever points we are going to plot. All right, so here are the rest of the points. So let's recap. Here are the first 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Okay, so it's very easy to go from E to F like this. But remember, R is going to be 0 somewhere in between. So you actually have to pass this way. We will actually look for that angle in a couple minutes. Okay, so after point I, we have symmetry going on. So this point H is reflected to point J. New angle 7 pi over 6, but R is the same. So similarly, 3 pi over 4 is reflected to 5 pi over 4 with the same R. And we keep going. Basically, just duplicated those points above to make these new points, but changing the angle to reflect it, subtract basically the original angle from pi due to the symmetry of the cosine function. So from I to J to K to L, and once again, we will go from L to M, but we are going to cross the pole in between. Okay, where does that happen? And then from M to N to O to P, and then Q and A are the same point. Okay, so if you don't believe me, let me hide Q for a minute. Boom, there is point A. Of course, why would I lie to you? Okay, so now we graphed the circle earlier. So let's do it for this new polar curve. So the equation is R equals 8 cosine of theta. So I'm going to need the keyboard, and theta, once again, go to ABC, ECS 1, 2, 3, Greek, and there's theta. Ooh, okay, so that was the original. But of course, we have the plus 3. Ooh, boom. All right, so let me close the keyboard. So we get, there you go. We get the full treatment. All right, so I wasn't lying to you. From E, we go to F, but somewhere in between, we are going to get 0. R is 0. And then we go to I, J, K, L, and then once again from L to M, we pass through the pole. Okay, so that is what we're going to do next. Find out where, we know that we cross the pole at the pole, but what is the angle at which we cross the pole? And we're going to do it twice. All right, so here's our equation, and we want to know, when do we cross the pole? So to cross the pole, we need R equals 0. So of course, we are going to set this to 0. So what does that mean? Cosine theta must be negative 3 over 8. Okay. So what angle or angles between 0 and 2 pi do we have where the cosine is negative 3/8? Okay, so first of all, cosine is negative in the second and the third quadrants, okay, which makes sense because it happened on the left side of our polar graph, but also from above. Oh, that was the first quadrant. What's going on there? So, well, we can use the arc cosine function. So we can we will have two solutions. We cross the pole twice. Thus, the two angles where we have cosine is minus 3 over 8 are. So one of them, let's call it alpha. Pardon the interruption. Alpha is arc cosine, arc cos of negative 3 over 8, and what's the other angle? Let's call it beta. Okay, so how do we get another angle? We're going to use symmetry. So two angles have the same cosine, one above the other. What do we do with this angle alpha? We subtract it from 2 pi. Or another way to think about it is we get the negative of that angle. So we can say it is the negative of alpha, except you're going to say, wait a minute, so that's not between 0 and 2 pi. So if you want an angle between 0 and 2 pi, we will choose 2 pi minus alpha. Okay, so let's actually get approximations for this. So let's do that later. What is arc cosine negative 3 over 8? Boom, it's about 1.955. That's in radians. Okay. So, and the other point is this. So we need 2 pi minus this angle. 2 pi minus, whoops, sorry, slippery fingers. 2 pi minus arc cosine negative 3 over 8. So we get 4.327 radians. Okay, so these are approximations, of course. So we can check our answer. We are supposed to get 0 for both of these angles. So let's plug in alpha. So we will get alpha is this angle. Copy that in. Whoops, put parentheses just in case. And let's approximate. And we get approximately 0. That's a ridiculously small number. So the other one is for beta. And we're going to get, for beta, we will plug in this other angle, approximately. And again, we should get something very close to 0. So, dear Maple, yep, very close to 0. Slightly different, okay, because of course these are approximations. Okay, so that gives us the two angles at which we cross the pole. And these are going to be important because in our next topic, we are going to find areas bounded by polar curves. We're going to look for the area of that inner loop. One more thing. Why is it that, okay, this angle is in the third quadrant, but why is it that the curve is being traced in the first quadrant? Okay, but that is because our r is negative near that angle. And so we're actually in the first quadrant instead of the third quadrant. Okay, so yeah, I kind of decided that it's already half an hour. We shall end this video soon. We will continue with a second part 2. We're going to do a couple of things before we leave. Right now we have 8 cosine theta plus 3. So just like circles, let's see what happens when we change our graph to sine theta instead of cosine theta. 8 sine theta plus 3. Then we'll play a little bit. We'll change to plus 3 to minus 3. We'll change to plus 8 to minus 8. Let's see what's going on there. Surprise! We are back in GeoGebra, but this is not the same program that we were looking at earlier. It's the same curve, of course. There it is, 8 cosine t plus 3. So this is a little bit fancier. I wrote this section of code. We're not plotting individual points because we already know what the curve looks like. Okay. However, here's what I want to show you because you will have access to this code. I will save it and make it available to you. If you're watching this on YouTube, it's going to be in the video description, something you can download and use in GeoGebra. Okay, so right now it's in Cartesian, and let me hide the curve that we started out with. Okay, I have in this program the ability to graph the function which produces this, what do you call this? This polar curve. Okay, so if I show this, I see the Cartesian function y equals 8 cosine x plus 3. Okay, so it is a graph of x versus y, not polar, Cartesian. I like to think of this as a helping graph to help us to analyze our polar graph. So notice that we're going from 0 to 2 pi. Okay, so you can actually see the bounds over here. 0 to 2 pi, about 6.28 or 6.3. And remember our values. Okay, we started with 11, and then we went down to -5, and then back to 11. This is a good helping graph because we actually see that cosine is going to be 0 at these 2 points. Okay, and remember, we saw the approximations for those alpha and beta. You would recognize that those two numbers are close to those points. They should be exactly the same. Okay, now, instead of staying in Cartesian, which is this, let's go to polar. So right-click on the grid and go to Show Grid, and underneath there, you will see the polar option. Okay, so if you click on that, you get, polar coordinates. I believe we saw this in an earlier video. Of course, our Cartesian graph doesn't quite make sense anymore. Just have to remember, we're going from 0 to 2 pi, plus 11 to -5. Okay, so now let me show you this. I will show 2 points, okay? One point is A, it's on the graph of the sine curve, the cosine curve. And then here's the point B, which will be the corresponding point in polar coordinates, r theta. Okay, we will also show the corresponding angle that is produced by this point A. Okay, so the angle is going to go from 0 to 2 pi, right? So we have this slider over here, and it's going to go from 0 to 2 pi, and in so doing, we will trace the function. So here we go, play. Ooh. So notice that A is getting lower and lower, which the R is getting shorter and shorter until it gets to 0. I'm going to pause it for a little bit. So A is getting close to the x-axis, R is getting close to 0. So the point B is getting closer to the origin. This segment command is what enables us to draw the segment from the origin to point B. So notice that the R value is 2.414, which is the same as the F value, 2.414. Okay, so let's keep going until we get close to 0. Play, and boom. Okay, so our R is, where's our R? Very small. I can't get it to stop exactly at 0. But the angle is, where are we? 1.96. That was about our first angle, where our alpha, when the R is close to 0, equal to 0. Okay, keep playing. And now we see that the R is negative. Okay, we have negative 1.7. And since we were coming from the second quadrant, going backwards, we're now in the fourth quadrant. Okay, so keep going, and we are going to reach -5 for the R, and that is when, boom, we are on the x-axis once more. Okay, because that was where our angle is at pi. Okay, so there it is. That's approximately pi. Okay, notice that our R is -5, so we're definitely in negative territory here. Our angle is actually in the third quadrant, but because R is negative, we're bounced to the first quadrant. Okay, so we're getting close to 0 once again, and boom, there we go. Our point is at the pole once more, and the angle is about 4.34, what we got for beta. Okay, so keep playing, and boom, there we go. And we are heading on our way back to our starting point at 11 0 in Cartesian coordinates. Okay, and there we go. Okay, so of course we can see the entire curve, and let's play that again. See how it traces out. So follow the A and the B. Okay, it's getting lower, and it's there on the curve. A is getting close to the x-axis, so R is getting close to 0. Now R is negative, so we're going backwards, and it's going to stay negative until we go back to this point. Our beta, it's still there, so R is still negative, and it's going to get to 0. We hit the pole, and then it's going to stay positive and keep getting bigger until we get to 2 pi. The end. There you go. Actually, no, because we said that we will change the cosine to sine. Okay, I'm going to pause the video because sometimes GeoGebra gives me issues. Yeah, so predictable. It was giving me issues. Okay, so this time it is 8 sine t plus 3. So again, the blue curve is in Cartesian. Sine goes like this, from 0 to, 2 pi. Sorry, I clicked on the slider. So because we're adding by 3, the curve shifts up by 3. So this tells us that the starting point, the starting R value is 3 when theta is 0. So we're on the x-axis as usual. We start at theta is 0. And then your R is going to get bigger and bigger until it reaches its maximum value at pi over 2. So that's what we have over here. And it will keep going until your R is 0 once again. So no surprise, we're still going to hit 0 twice. And then we go back to our starting point. Okay, let's play the slider. And let's go. Okay, there you go. A is getting higher, so R is getting bigger. And it's approaching pi over 2, and pi over 2 is up there. And then it's going to get lower, so R is now getting smaller as the angle is approaching pi. Sine of pi is 0, so R is 3. R is 0 over there. And then it's going to get its smallest value at -5. So this time, 5 is there on the y-axis. And then it's going to approach 0. Once again, we are going to hit the pole, and then it is going to go back to where we started. Woohoo! Okay, so what happens if we change the +3 to a -3? Okay, so let's see if GeoGebra gives me any grief here. Hopefully not. Okay, so 1, 2, 3. Ooh! Notice that the graph of the sine wave flipped over. I need to shrink it a little bit so we can see it. But the graph of the curve did not change. Okay, let's play the video. Let's see what happens. Back to 0 and play. Okay, so it starts this time on the left, different starting point. And we get to the 5 over here. So this time it's +5 at pi over 2. And then we get the second 0. And then at pi, we're going to get that point. And then at 3 pi over 2, we're going to get this point where now the R is going to be -10. And we're going to go back to where we started over here. And there we go. Okay, so last thing, let's change the minus 3 back to a plus 3. Let's see what happens if we change 8 minus 8. And ooh, okay. So that was a big change. The sine graph flipped over because we have minus 8 this time. The graph of the polar curve also flipped over. So back to the starting point. Oops, I'm sorry. And get over, grab the slider. Come on, grab this. What is up with you? Okay, when all else fails, change it back to 0. Okay, so we start over here, and r is positive 3, so we start here in the polar curve. Play. We get 0, we're at the pole. It's negative, so we're going backwards. And then we're going to get the, what is that? Negative 5. So instead of at pi over 2, we are in the opposite direction, back to 0. And then the r is getting bigger and bigger until we get to 11. And that will happen at 3 pi over 2, where we have a positive 10.89. And then it's going to go back to the starting point. Our r is getting smaller now as we get back to the x-axis where we stop, right there. Okay, so I hope you had fun there. We will have a part 2 for this video where we are going to find tangent lines. Okay, we can kind of see that at the bottom here we have a horizontal tangent. Over here as well we have a horizontal tangent, and on the right we have a vertical tangent. We don't see, we actually saw this when we did our parametric curves. We have vertical tangent lines, but when we get to the inner loop, we also see that we get vertical tangent lines here and here, and horizontal tangent lines here and here. So that's actually probably the same line that passes through those 2 points tangentially. All right, so I hope you enjoyed that, and we will continue in our next video to find those points of tangencies. And until then, I hope you enjoy the rest of your day. Bye.